Mars, the fourth planet from the Sun, has fascinated humankind for centuries. Its rust-hued surface, colored by iron-rich minerals, and its bitterly cold, thin atmosphere have fueled countless stories of extraterrestrial civilizations. On top of that, this small yet intriguing neighbor holds the title for having the largest volcanoes, mountains, and valleys in our entire solar system. Astronomers once believed that Mars might harbor living organisms and host vast oceans, giving rise to legends of ancient Martians. Now, as environmental concerns threaten our own planet, some visionaries suggest that humanity's future may lie on the red planet. But is it truly possible for humans to live there? And if so, what formidable obstacles stand in our way? Ever since Galileo Galilei first turned his telescope on Mars in the early 17th century, we've been captivated by its potential. Soon after Galileo's initial observations, astronomers discovered that Mars had polar ice caps, spurring debates over whether the planet might have conditions like those on Earth. During the 19th and early 20th centuries, certain researchers claimed to see extensive canals on Mars, which they interpreted as evidence of an advanced civilization. Although these canals turned out to be illusions, Mars's hold on our collective imagination has never faded. In the early 1960s, robotic spacecraft became our first emissaries to the Red Planet. America's Mariner 4, launched in 1964, returned the first close-up images of Mars, shattering the romantic notion of a planet teeming with vegetation or cities. Following that, Mariners 6 and 7 in 1969 confirmed that Mars was a barren, cratered world with no signs of intelligent life, at least not on the surface. The Soviet Union attempted their own Mars missions, but many malfunctioned or failed to deliver conclusive data. Two of their probes, Mars 2 and Mars 3, did operate successfully, though intense dust storms hindered surface mapping. The real turning point came on July 20, 1976, when NASA's Viking 1 lander touched down on Martian soil, capturing the first high-resolution images from the ground. People hoped to see at least traces of life, perhaps microbial colonies or the remnants of ancient structures. Instead, the Viking missions found a desolate landscape. On the bright side, they also photographed amazing geological features, including Olympus Mons, a volcano roughly 3 times the height of Mount Everest, and the sprawling Valles Marineris, which stretches about 4,000 kilometers, 2,500 miles, across Mars's surface, making it one of the solar system's most dramatic canyons. Fast forward 2 decades to 1996, when NASA launched Mars Pathfinder and the Mars Global Surveyor. Mars Pathfinder carried Sojourner, a tiny 25-pound rover that wandered 100 meters, 330 feet, over 83 days, returning photographs and valuable data about Martian soil composition. Meanwhile, the Mars Global Surveyor orbited overhead, gathering high-resolution images of the planet's terrain. In 2001, NASA's Mars Odyssey probe discovered abundant water ice just beneath the surface, particularly in the upper meter of Martian soil. Although Odyssey's instruments couldn't see any deeper, the discovery suggested that far more hidden ice, or even liquid water, might lie below. In 2003, Mars swung closer to Earth than at any point in the previous 60,000 years, which NASA seized as an opportunity to dispatch 2 new rovers, Spirit and Opportunity. Tasked with searching for past water activity, each rover landed in different areas. Both succeeded beyond expectations, discovering traces that once, long ago, Mars had flowing water. Originally planned to last just 3 months, both rovers heroically kept rolling for years. Spirit's mission ended in 2010, while Opportunity operated until 2019, an extraordinary testament to the durability of human engineering on a harsh, alien world. Building on these successes, NASA sent the Phoenix lander to the planet's northern plains in 2008. Phoenix confirmed the presence of water ice and studied the local geology and climate. Although it was never designed to survive the brutal Martian winter, Phoenix still exceeded its mission parameters before succumbing to the frigid environment. In 2011, NASA's Mars Science Laboratory launched the far larger Curiosity rover, equipped with advanced instruments for analyzing rocks and soil. Curiosity not only relayed spectacular images, but also identified what appears to be an ancient stream bed, strengthening the argument that Mars once featured rivers, perhaps even seas or oceans. Despite compelling evidence of ancient water flows, we've uncovered no definitive proof of past or present Martian life. That hasn't stopped enthusiasts from sharing images with alleged alien artifacts, faces, or even spider-like forms in the shadows of Martian rocks. But these often turn out to be tricks of light or optical illusions. So, if Mars appears to be lifeless, why spend so much energy and so many resources trying to visit or settle it? The question sparks heated debate. One angle is that terraforming Mars, making it more Earth-like, might be theoretically possible. However, scientists suggest that process could take hundreds of thousands, if not millions of years. Critics argue that focusing so heavily on an uninhabitable planet is wasteful, pointing out that human needs here on Earth are pressing and demand immediate attention. Yet proponents of Mars exploration insist there are multiple justifications. Mars is our planetary neighbor, relatively easy, in cosmic terms, to send missions to, and it once held many of the same qualities that Earth had. Thus, it provides an unmatched laboratory for studying planetary evolution. Scientists hypothesize that in its younger days, Mars had a denser atmosphere with enough warmth to support rivers or shallow seas. Over time, dramatic climate shifts stripped away this atmosphere, leaving behind the cold, arid terrain we see now. By understanding the processes that shaped Mars, we gain clues about how planetary environments can change, and maybe how to prevent or adapt to similar changes at home. Visionaries such as Elon Musk have taken these ideas further. Musk's company, SpaceX, wants to transform humanity into a multi-planet species, establishing a permanent Martian settlement. Although the planet's surface pressure remains extremely low, just a fraction of Earth's, Musk believes a sufficiently advanced technology could release enough gases from Martian soil or polar ice caps to thicken the atmosphere. One radical proposal he once floated involved detonating nuclear warheads over the poles, instantly vaporizing the ice there to jumpstart a greenhouse effect. While nuclear weapons can be engineered to produce minimal radioactive fallout, questions remain about whether Mars actually has enough carbon dioxide stored in its soil to build a stable atmosphere. Studies show that the total CO2 available might only generate about 15 millibars of pressure, vastly shy of Earth's 1,000 millibars at sea level. An even more daunting obstacle is the absence of a global magnetic field. On Earth, our molten iron core generates a magnetic shield that deflects hazardous solar wind and cosmic rays, preventing our atmosphere from being whisked away into space. Mars once had a similarly convecting core, but around 4.2 billion years ago, something shut it down. Some scientists propose that hydrogen accumulation released from water molecules inside the planet's mantle might have slowed or halted convection. Whatever happened, Mars lost its protective shield, and solar wind gradually stripped its atmosphere to the thin veneer we see today. Even if we artificially constructed a dense Martian atmosphere, it wouldn't endure without a robust magnetic field. Until someone devises a high-tech fix, maybe an orbital magnet shield or a way to reignite the Martian core, the new atmosphere would steadily erode away. So, why do it at all? SpaceX and other organizations envision setting up bases as early as 2024, aiming to send cargo missions and eventually human crews. Building a small outpost on Mars would represent humanity's greatest leap since the Apollo moon landings, generating enormous public excitement and scientific data. Beyond that, many worry that Earth faces a variety of potential cataclysms, from natural disasters like supervolcano eruptions to human-triggered climate change and resource depletion. Over an even longer timeline, our aging sun will expand, making Earth uninhabitable. To some thinkers, ensuring our survival means spreading our civilization across multiple worlds, hedging our bets against extinction events. Establishing a colony on Mars wouldn't be just an engineering challenge, it would be a life-changing experience for the brave souls who attempt it. Astronauts would need to bring or generate all their necessities: oxygen, water, food, radiation shielding, power systems, medical supplies, and housing. The plan would also require some structure for governance. Mars settlers would likely develop local Martian laws adapted to an off-world environment where every breath and drop of water is precious. Elon Musk has even shared conceptual art of a sprawling Martian city where glass dome structures, power plants, and farmland might keep a self-sufficient population alive. While it sounds like science fiction, it's not as far-fetched as it once seemed. SpaceX is already testing its Starship vehicles at the Boca Chica site in Texas, with the goal of sending humans back to the moon and soon after to Mars. NASA is making strides with the Artemis program, aiming to establish a sustained presence on the moon by the end of this decade. From there, the leap to Mars may occur in the 2030s or 2040s if technology and funding align. Some optimists even predict that we might see a functioning Martian habitat by the mid-21st century. Still, many remain skeptical. William "Bill" Anders, one of the first astronauts to orbit the moon during the Apollo 8 mission, has publicly called a crewed voyage to Mars almost ridiculous, given the gargantuan expense and uncertain returns. Indeed, colonizing Mars won't be cheap, and the challenges are daunting. Yet the lure of exploration and the possibility of giving humankind a backup planet remain compelling. If Earth ever faces a catastrophic threat that renders it inhospitable, be it an asteroid impact, massive climate crisis, or something else entirely, we might be glad we planted our flag on Mars. Ultimately, Mars stands at the crossroads between bold optimism and harsh cosmic reality. On one hand, it's a bleak frozen desert, scorched by radiation and lacking both a breathable atmosphere and a magnetic safeguard. On the other hand, it's a place of stunning landscapes and untapped possibilities, close enough to Earth for robots and soon humans to explore firsthand. For many, it represents the next giant step in our growth as a spacefaring civilization. Someday we may fully resolve the obstacles of terraforming, atmospheric retention, and radiation shielding, transforming Mars into a distant second home. Until then, both skeptics and dreamers will argue about the value of sinking time and resources into a frozen rust-red realm. Yet if we succeed, we'll be able to look back on this moment as the dawn of interplanetary life. Who knows? One day, you might even have the chance to volunteer for a one-way trip, helping to establish humanity's first foothold on an alien world. Would you seize that opportunity? Thank you for joining this deep dive into the ongoing quest to explore and potentially inhabit the Red Planet. If you enjoyed this expanded look at Mars and its challenges, consider subscribing and turning on notifications so you'll be first in line when we release more cosmic content. Until next time, keep dreaming of new horizons and maybe, just maybe, preparing for your own Martian adventure